开始吗？
好。
Hello everyone. This is Group 5, and we are working on the Kaggle competition. This is our table of contents. First is the overview of the competition. The competition's object is to detect when users fall asleep and wake up by their time series sensor data. And we got two key insights from data visualization. First, there are two main tendencies in raw data, jumping process and diffusion process. When it is in jumping process, the movement is huge compared to diffusion process. Also, we found that event type is often changed when sensor data change between the two processes. So we want to let the model to understand these two processes. Secondly, we found that daytime data is also related to event type. In the lower figure, blue one is the occurrence of onset, and orange is awake. We found that onset and awake often occurs in specific time, so we want to utilize the relationship in our model.
Next is the things we did. For feature engineering, there are several types of possible features. First, the statistic information over a period of time. We take different rolling methods on angle Z and ENMO. These features can show the behavior between the time period. Second, since we usually fall asleep around a certain time, but directly treating the hour and minute as numeric data may lose some information. For example, 11 p.m. is closer to midnight compared to 7 p.m. But if we treat hour as numeric data, we will find that 23 minus 0 is larger than 19 minus 0, which is wrong. So to interpret the timestamp, we should convert them into periodic signal, and it can be done by taking sine or cosine of hour and minute of timestamps. Finally, we add shift to raw data. This is a common technique when processing time series data, and we believe that it can help model to better understand the local feature. We test the feature importance and found out that hour and hour sign has the highest importance. So we take this feature into our model. Then we choose different combination of features and test. After our experiment, features containing hour sign actually perform the best. And here are the final features we select.
So after feature engineering, we'll move on to the model design. Intuitively, we'll view them as a time series problem and choose recurrent model. So we use a GRU block in the middle. Moreover, we have observed that sometimes a local pattern itself can be a significant feature, such as the variation in angle Z. So we also utilize convolutional layers to extract the features and feed to the GRU block. Overall, the model will be like a U-shape. The left part is an encoder, extracting features from the image, and the middle part is a recurrent block. The right part is a decoder, which utilizes the features to generate predictions for each point. So after generating diverse features and model designs, we want to further leverage them by integration, or let's say ensemble. We integrate them by first generating predictions with each of the model, and combine their predictions with a design method to utilize both of their strengths. We choose two models for ensemble. The first one is the top performing models we can get, which utilize both CNN and transformer. And the second one is the fast RCNN.
Okay, however, the ensemble method is not easy as we thought, so let's talk about the biggest challenge we have encountered. The result of the first few ensemble experiments are quite bad. We get 1 plus 1 less than 1, which means that the ensemble result is worse than both of the original results. After discussion and observation, we inspired by a graph that Professor mentioned in class, which is that we should combine two different perspectives of the model for getting better score. But how? The idea is keeping the row from the model 1, which is the better model, and change the confidence score by multiplying a weight based on how close of the two models' prediction steps. In another word, we mainly base on the result from the model 1, and that the intersection part have higher confidence score. So the detail of the parameter settings are as follows. The left-hand side have best probability score, which is based on the 3-step threshold. If the two models have the same event prediction under the step threshold like 12, then the output confidence score will be model 1 confidence score times 1.5. And the right hand side is based on 4 steps thresholds, which get the best score on the private leaderboard. This is our submission records. We have tried different parameter settings to get the best result. And this is our public leaderboard. Our ranking is 193. And this is our private leaderboard. Our ranking is 275. And the last part is the lesson we have learned. The first is 1 plus 1 less than 1. And the second is less is more. The meaning is that sometimes we use less feature can get a better performance. And third one is the following is quite important for us to get the idea from others. And that's all. Thanks for listening.